"50 years ago, this past July, humans set foot on the moon for the first time and redefined how we think about our planet. Every time you've ever seen a person walking on the moon or in space, they've been wearing a spacesuit. The spacesuit embodies what it means to be a part of humankind, to explore, and to achieve something we thought was impossible. But it's not just a simple piece of clothing. The spacesuit is one of the greatest technical engineering feats ever achieved. It does everything a spacecraft does to keep a person alive, except it's wearable. But despite how advanced it is, the spacesuit is surprisingly dangerous to wear. You'd never know just by looking at it, but this suit injures astronauts. Bruises, sprains, pinched nerves, and even lost fingernails. 23 astronauts have needed shoulder surgeries to repair injuries like torn rotator cuffs. If something like that happened on the surface of the moon or Mars, it could destroy the mission. Bottom line, improving the spacesuit is one of the biggest barriers to human space exploration that no one's talking about. I believe one of the most important things we can do to advance science is to send a human to Mars. We've learned so much from our robotic explorers, but they're so limited. One person on that planet's surface could unlock the history of how our solar system formed, or possibly even how life began. It'll take billions of dollars to send people to Mars, but you don't just go to Mars to stay inside your habitat the whole time. Astronauts will be exploring and wearing the suit a lot. With current NASA plans, if you sent 5 people to the surface for 500 days, that'd be about 1,000 spacewalks over the course of one mission. For perspective, we've done just over 400 spacewalks in the entire history of human spaceflight. That's an insane jump in capability. If we're gonna pull this off, and I believe that we will, we need to radically redefine the spacesuit. I became interested in space exploration in the 3rd grade when my teacher spent the day telling us about astronauts. It was the first time I really understood that people could go there. Since that time, human spaceflight has been the driving passion of my life. But I only began to understand how hard it is for astronauts to work inside their spacesuits when I went to graduate school. The spacesuit is pressurized with oxygen to allow people to breathe, but that pressure makes it stiff and rigid. Think about trying to make a balloon animal. When you bend the balloon, it wants to spring back to its original position. Engineers have tried to solve this problem by designing the suit's joints with pleats and bearings, but it still forces people to move in awkward and unnatural ways. To move in the suit, first you have to move your body until it makes contact with the suit. Only then does the suit itself start to move. You can't just reach up and touch your head like this. Instead, astronauts have to roll out their shoulder and then bend their elbow to touch their helmet. That's hard enough to remember how to do here on Earth, let alone when you're outside your spacecraft, traveling at over 17,000 miles per hour. Fit is another major issue. In March 2019, NASA had to cancel the first all-female spacewalk because the suits available didn't fit the crew members, and it would have taken too much time to put together a different suit on orbit that was the right size. So pressure plus fit is why astronauts get beat up every time they work inside the suit. And that's why I've dedicated my career to designing a better spacesuit. The first step is to understand how people move while wearing the suit. You can't just see inside to understand how and why astronauts are getting injured. So, together with my students at CU Boulder, we're developing wearable sensors to go inside to measure how people move and interact with the suit. With this data, we hope to be able to predict whether or not the suit will be comfortable or cause injuries after someone wears it a couple hundred times. When humans take their first steps onto the surface of Mars, their boots will make the first impact. Astronauts haven't needed to walk in their spacesuits since Apollo astronauts left the moon in 1972. Because the boot is also pressurized, the foot isn't secured inside of it. It'd be like wearing a pair of hiking shoes that are several sizes too large for you. Every time you take a step, the heel lifts out of the back, causing blisters, wasted energy, and awkward movement. The thing is, if you get a blister on a hike, you just have a bad hike. If you get a blister on the surface of Mars, it's hard to do your job. And it can be even more painful than that. One astronaut had a boot issue they said felt like a knife's edge of pain. To design a better spacesuit boot, my student Abby has built a 4-dimensional motion capture system that measures the shape of the foot while walking. With this data, we plan to redesign how the foot fits inside the boot to ensure our astronauts can explore further and further. But if we really want to revolutionize spacesuits for Mars, we have to protect the body in a fundamentally different way than we do now. I believe the solution for a Martian spacesuit relies on a skin-tight elastic concept first proposed in the 1960s by Dr. Paul Webb. It uses a concept called mechanical counterpressure, which means that rather than using an inflated garment to apply pressure to the skin, the suit itself squeezes the body. Unfortunately, these suits have never really gained traction because it's so difficult to create pressure over the complex shapes of the body, like the armpit. When I was a graduate student, my advisor sent me to Italy to work with a company, Dainese, that designs motorcycle racing suits. David told me, "These people are the best designers you will ever meet. I want you to use your engineering skills with their design skills and design some mechanical counterpressure spacesuit prototypes." So off to Italy I went. That summer was one of the most creative and inspiring experiences I have had as an engineer. Every day, Stefano and I would whip up some new spacesuit prototype, test it, and then change the design. Always getting closer to a mechanical counterpressure spacesuit, but we're still a long ways away from something that's spaceflight ready. Since that time, I've continued to work with this team of friends from MIT, the University of Minnesota, the Royal Melbourne Institute of Technology in Australia, David Clark Company, and NASA to continue pushing on these design issues. In my lab now, we're challenging how we think about using mechanical counterpressure in spacesuits. Instead of choosing either mechanical counterpressure or gas pressure, why can't we choose both? If we cut the design problem in half and apply, say, 50% of the pressure with a tight elastic suit layer and the other 50% with a traditional gas pressurized suit like we use now, we'd be able to protect our astronauts with a suit that's less stiff and rigid, but also safer through redundancy. And a suit like that would enable a human mission to Mars. I believe I will be lucky enough to see people walking on the surface of Mars before I die. But to make a mission of that magnitude worthwhile, we have to ensure our astronauts stay safe. And we have to ensure they're able to explore and do science day after day after day. It's time to imagine a new design for our iconic spacesuit. Thank you.